Very good. So shall we start?
Yes, sir. Okay, welcome, sir. Yes. Before we start our session,
I cannot hear you.
yes, sir. Are you audible, sir? Sir, are you hearing me? Hello.
Hello.
Hello. Now
Hello, sir.
yeah, can you hear me now?
Yes, sir. Definitely.
Yeah, earlier there was some problem.
Yes, sir. No problem.
And now it's okay?
Yes, it is okay. Okay, welcome, sir. Before we start our session, let me give the introduction to today's expert, Dr. Mohan Kolhe, sir, from the University of Agder, Norway, is professor in electrical engineering with focus in smart grid and renewable energy. He has also received the offer of excellent professorship in smart grid from the Norwegian University of Science and Technology. He has more than 3 decades academic experience at international level and renewable energy system. He is a leading renewable energy technologist and has previously held academic position at the world's prestigious universities like University College London, University of Dundee, University of Vakla, Finland, and Hydrogen Research Institute, Canada. Professor was member of the government of South Australian Renewable Energy Board from 2009 to 2011 and worked in developing renewable energy policies. Professor Kolhe's academic work ranges from the smart grid integration of renewable energy system, home energy management system, integrated renewable energy system for hydrogen production, techno-economics of energy system, solar and wind energy engineering, development of business models for distributed generation. Professor Kolhe has been successful in winning research funding from prestigious research counseling for this work on sustainable energy system. He has published extensively in the area of energy system engineering. He has been invited by many international organizations for delivering expert lectures. He has also been member of many academic promotional committees as well as expert member of international research counseling. Thank you so much. Thank you, sir. Now, I would like to hand over this session Professor Dr. Mohan Kolhe, sir. Thank you.
So thank you very much for giving so nice introduction. And today morning, I would like to talk with you or to share my experience on smart home energy management system. And I'm very much thankful to Dr. Nikunj Patel of your institute for inviting me to share my knowledge and experience on smart grid and renewable energy system with the participants. And my apologies for not accepting the morning session because due to the time difference. So I had to select this time slot. Now I want to share my screen with you. So just give me 1 minute. Okay.
Okay, sir.
Yeah, please share screen. So now you can see my screen.
Yes, sir.
And now I'm putting it in the full view. So it is coming okay now in the full
Yes.
screen.
Yes.
And you can see me also.
Yes, sir.
Very good. So because now when I put on the full screen mode, then I cannot see myself. Okay, that's why I'm asking. Good. So if you have any technical problem with reference to the presentation or viewing the presentation or hearing me, please tell me. Okay.
Okay.
So this is a good afternoon to everybody, and it is a good morning from here. So here it's around 9 o'clock in the early morning, and we have very nice weather now. After a couple of days, we have nice sunshine with a temperature of around 5 to 6 degrees, and a little cold and chilly, but some sunshine. And I hope that in Gujarat there may be a very good temperature, maybe around more than 20 degrees centigrade. I hope so in Surat. So taking forward, because I know that most of the participants, they are from electrical engineering background, and the key focus of today's lecture is on smart energy management system. And we know that now we are talking about the smart grid, and in the smart grid the main issues are there, how we are going to use or how we are going to utilize information and communication technologies infrastructure for making our electrical energy network more smart. We know that our electrical energy system or electrical power system is having different layers. If we move towards the high voltage side, which is already very smart, and also the medium voltage level, that is also up to some level it is smart. But if you come on the lower voltage side or the distribution side, then that network is not that smart. It is most like maze. And in a distribution network, we know that we are going to get all the electrical energy from the upper end, and in the distribution side we are mainly, or we were focusing mainly on the consumption side. But now, due to increasing penetration of intermittent renewable energy sources, maybe at the higher voltage side or medium voltage side, and even including within the distributed network, we need to make our distributed network more smarter. So for that, we have to utilize the information and communication technology infrastructure. So here, in today morning's lecture, I have taken one example or one case study of one of my project, which was funded by European Union Framework 7. And that project, it was focused on how we are going to utilize the existing information and communication technology for making some modification or by installing some intelligent devices within the distributed network for operating it within the smart grid environment by managing or by shifting the operation of non-critical power intensive load in cooperation with intermittent renewable energy sources. So that is the key theme or the high level theme of today's lecture. Okay, and I'm dedicating this my lecture to my father, who has passed away recently on 24th August, and who was a retired primary school teacher also. Now, at coming back to the University of Agder, where I am working, here I have led 3 big projects on related to the smart grid. One project, it was on electricity usage in smart village, scarpness, that is a building integrated photovoltaic system, which has been funded by the Norwegian Research Council in cooperation with local industries. Then second project, which I am going to share with you in much more detail, that project, it was scalable energy management infrastructure for aggregation of households. In short, we called it SEMIA, which was funded by the European Union 7th Framework Program. Another project which has been completed last month, it was funded by Royal Norwegian Embassy, New Delhi, and it was in cooperation with the Energy Resources Institute, TERI, and University of Agder on the theme of sustainability and clean energy. In all these three projects, basically the idea was that how we can make the distributed network more smarter so that we can have more integration of intermittent renewable energy sources. One point. Second point, how we can manage or how we can shift the operation of non-critical power intensive load through demand side management in cooperation with renewable energy sources generation or the production. Then another thing, when we want to make our distributed network more smart, and then of course we want to integrate more renewable energy sources, for example building integrated photovoltaic system, then under this TERI UIA project we have developed microgrid architecture for managing the production of solar photovoltaic sources in cooperation with the energy sources and distributed generator by considering the economics of distributed network, for example electricity pricings, as well as the techno-economic analysis for the of renewable energy sources which we are going to connect. And under the TERI UIA project, another very good thing which we have covered, that one was related to how we are going to do the recycling of solar photovoltaic modules as well as the battery, because we know that in India, or not only in India but in all over the world, there is an increasing penetration of solar photovoltaic system. And we know that, so every system has a technical limited lifetime. So same is going to happen with solar photovoltaic system. Whenever the solar photovoltaic system, they are going to come at the end of the life, then we have to think that how we are going to do the recycling of the solar photovoltaic modules, how we have to develop new policies for that, and what new business opportunities are going to be there for recycling of solar photovoltaic. So that have also been covered under the TERI UIA project, which has the theme of sustainability and clean energy. If we come back to the first project, that is electricity usage in smart village scarceness, which has also completed. So in that project, we studied a group of houses, around 36 houses, which were integrated with photovoltaic system and with very energy efficient equipments, and then we monitored the performance of such type of houses with reference to the grid, how they are behaving with the grid under such type of system, what type of new business models have to be developed by the utility company for promoting the building integrated photovoltaic system, how such type of systems are going to impact the power quality of the distributed network. That also we studied under the first project. But today I am going to focus on only one project, that is scalable energy management infrastructure for aggregation of household. Yes. So now you can see my slide now, new slide. Hello. Hello. Are you able to hear me?
Yes, sir. Yes, sir.
Yeah, very good. Because I thought because I lost connection. So
No problem.
let me
It is
update.
okay, sir. Yes.
Yeah, very good. So this project, it was funded through competitive process from the European Union under 7th Framework Program. And the objective of 7th Framework Program was for how we can have the research, technology development, and demonstration. And under this project theme, where the key idea was that how we are going to utilize information communication technology infrastructure for promoting the energy management system. Okay, so under this call, there were around 66 applications, and out of 66 applications, only 4 proposals they have been funded. Out of 4 proposals, this proposal or this project, I can say, is one of them. And for this project, my role, it was a technical manager, and there were 12 partners from 4 European countries. And the idea here was not only to do the research or to develop the technology, but also to implement that or to demonstrate that. Okay. If we take in a very simple way, energy management or demand side management, it looks like a very simple case, means that we have to shift the operation of non-critical power intensive load at some time when we have the more demand on the network, okay, or considering the grid constraints. It looks like a very simple, but here you will notice that when we want to demonstrate that in the field, considering the integration of information communication technology infrastructure, then this project is going to, or this work of demand side management is going to be very complicated. So the total value of this project, it was 3.8 million euro. It was quite high. And this project was started in March 2014 and completed in May 2017. And the funding scheme, it was related that to use of information communication technology for energy management, especially for the low carbon economy, and how this ICT can be useful, or ICT infrastructure can be useful for smart energy grids. And the target outcome from this project, it was a scalable ICT infrastructure to control electricity consumption from household appliances in an incentive-based demand response program. It means that in our houses, we have many type of appliances. Some of them are more power intensive and non-critical also. So we want to shift the operation of those selected non-critical power intensive load, considering some incentive based demand response program. And for that, how we have to use ICT infrastructure and how we can control those load, or how we can shift the operation of those load by sending the centralized information. Okay, so that one was the target outcome. And when we are talking about the demand side management or home energy management system, then of course we need to install some devices in the selected houses. And the device which we selected here, it was what we call it as a home energy management gateway, or we call it as a front-end system. And this home energy management gateway is of the size of a mobile, let's say, and it has all communication facilities also. So let's say if we are installing this device in some selected houses, then this device is going to get the information using ICT infrastructure from the centralized server, that we call it as a backend system or the virtual power plant, right? So based on those demand response or demand response signals which are going to be received from the by the home energy management gateway from the centralized server, Denmark, Switzerland, and Germany. From Norway, my university, there is University Agder or University of Agder, was a key partner, and I was leading this project as a technical manager to manage all the technical outputs and the technical things in coordination with all 12 partners. From Norway, Agder Energy Net was also the partner. Hardware and the software which have been used in this project. Then if we go to the Germany, from Germany, Fraunhofer IWES was the partner, and all of us, we know that Fraunhofer is one of the leading research organization in and well respected organization. So Fraunhofer, they have the expertise on renewable energy sources and also the facilities of virtual power plant. So we used in this project the Fraunhofer facilities of virtual power plant or the backend system. At the same time, they have also provided the operating system or the platform for the home energy management gateway. That was the OGEMA platform. I will explain you that in detail. Then we come back to the Denmark. From the Denmark, Aarhus University and Devolco Products, they were the partner. Aarhus University was coordinating the project, including finances, and the Devolco product, it was another organization from Denmark which produces this power conditioning devices or the components which are required for the intelligent control of the selected appliances. So here in this project, Devolco products, they provided the home energy management gateway as well as the plugs which can communicate with the home energy management gateway through Zigbee communication. And in the home energy management gateway, the OGEMA platform, which was a operating platform, let's say, was provided by the Fraunhofer, okay, and which we included in this home energy management gateway. Then the remaining partners were from Switzerland. From Switzerland, we have the CSEM. It was a research organization. They help us to do some analysis on the solar photovoltaic and demand side management integration. Then another company from Switzerland, it was a NetPlus. That was basically, it is the utility company. And at the same time, it also owns the information communication technology network also, or let's say as it was operating was is a company as a mobile operator also. Then another company here you will notice, Misorio. So they were quite good in analyzing the business models related to the smart energy system. Okay. Then here we have the HSSO, that is another academic organization, or the University Applied Sciences University from Switzerland, and they contributed in developing ICT infrastructure, more or less integrating the front end and back end infrastructure, okay, for smooth operation and control of this home energy management gateway. Then another company here, SEIC Teledis Group A, so that is also from Switzerland. So they were also quite good in ICT infrastructure in Switzerland. So here you can see that during this 3 years, 4 months project, in cooperation with 12 partners, out of 12 partners, only 3 partners, they are the universities, and the remaining partners, they are the industries. And at the same time, here you will notice that due to the regulation of the European Union, we need to have minimum 3 European countries as a partner. So here we have the 4 European countries, and you can see that how these different countries or the companies, they are located within the Europe at different locations, how smoothly they worked together in a very integrated way and executed this project. Now, coming back to the high level analysis or understanding of this project. In this project, main idea was that within the customer side, means we need to provide the flexibility, and we have to use that flexibility from the upper side or from the grid or the market side. Okay, and when we want to provide that flexibility to the customer side or distributed network side, so then naturally we need to utilize the shifting of the operation of non-critical power intensive load, and how this shifting can integrate or can help us in coordinating with energy storage, distributed generation in buildings, and so on and so forth. And the target was that how, with reference to this home energy management gateway or demand side management within the distributed network, by selecting the houses only, how such type of system are going to help in further integration of distributed energy resources, and at the same time considering the grid constraints or the markets also, and how that flexibility can be used in the customer domain, especially within the distributed network. If we come to the upper side, okay, so upper side we have the grid or the market. So from this upper side to this domain, customer domain side, we have to use the information exchange, or we have to do all the control through the information communications. So for that we need to utilize information communication technology infrastructure. We have to see how this grid can offer the flexibility, how the control signals are going to be provided here. Not only that, but at the same time we have to consider the market dynamics also. So all these factors have been taken into account in developing the project objectives. Okay, so now here you can see how the project objectives have been defined considering the high level information which have been provided on the previous slide. And then while developing the objectives, also the care has been taken that how the 12 partners expertise can be used in integrated way, and based on those key objectives, then how we can develop the work packages for these projects that I'm going to share with you. I believe that you are in a position to understand the high level objective of the project. So the high level objective of the project, it was basically we want to shift the operation of non-critical power intensive load considering the grid constraints by taking into account the information from the backend system or from the virtual power plant or from the main grid and getting it implemented in the home or in the home energy systems. Okay, so for that, the first objective, it was how we can develop the technical and functional design for smooth operation of such type of system. Okay, so this is a very challenging thing. So this objective, or that is a technical and functional design of scalable energy management infrastructure for aggregation of households. So here we used the expertise of the Swiss University HESSO, and they were in a position to lead this objective or contribute to this objective. Okay, how we can have the technical and functional design of such type of system. Then second objective is again very important, because when we are talking about virtual power plant or the backend system and we want to shift the operation of non-critical power intensive load, selected one, in the home, right? So, and we want to utilize the centralized information, centralized control. So of course, for that we need to utilize the existing information communication technology infrastructure. For that, we used 3G communication from backend system or the virtual power plant to the home energy management gateway, and then home energy management gateway, it was helping to shift the operation of selected loads. Okay, that has to be controlled through some communication. So Zigbee communication have been also used. So here you can see that in the objective 2, the how this ICT infrastructure have been integrated for smart energy management system. For that, or for this objective, the expertise from the Swiss partners, they have been utilized. Then next objective, that is a development of aggregator intelligence. So that is again, that objective is very key objective or heart of this project. In this objective, that we need to develop algorithm. So this algorithm which is going to be implemented in either into the home energy management gateway, if we are going to utilize the decentralized approach, if we are going to utilize the centralized approach, which we did in this project, then this aggregator intelligence or the algorithm which have been developed for home energy management system or for shifting the operation of non-critical load, that have been implemented into the backend system or in the virtual power plant, and based on that, then that home energy management gateway used to get the signal through 3G communication for shifting the operation of selected non-critical power intensive load. Is it okay to understand? I hope that everyone is in a position to understand. My communication is okay there? Hello?
Yes.
Yeah, yes. So are you able to hear me properly?
Yes, yes, sir.
Very good. Because I thought, because I
No,
maybe I
sir.
was the
No, you may
speaker.
continue, sir.
That's good. That's very good. So we will move further then. So the next objective, that objective 4 was that how we have to integrate the front end system and the back end system. So here the front end system means home energy management gateway, and the back end system, it means the virtual power plant. So how we have to integrate that? So now here you can see that from objective 1 to objective 4, basically we tried to do the research and develop the system which is required for shifting the operation of selected load or by reducing the peak demand on the network. But when we want to implement or we want to demonstrate these objectives, that let's say research and technology development, we want to do the demonstration, then here we used objective 5. That one was for the pilot testing and validation also, that I will explain you in much more detail. Here you can see that there were partners from 4 European countries. Okay, out of 4 European countries, 2 European countries, they have been selected for doing the pilot test of this system which have been developed under this project. So Norway and Switzerland, they have been selected for doing the pilot testing, and that for the pilot testing also, based on the recommendations from the European Union, we have to upgrade the pilots from 10 houses to 100 houses, both in Norway as well as in Switzerland also. So it means that we tested this, what with the research and technology development have been done, right, for 100 houses in Norway and 100 houses in Switzerland. So that have been covered under the objective 5. Then next objective, that is again very interesting and very important. Here you can see that we are using information communication technology. It means that all the signals are coming from the backend system to the front end, and also from the front end it is going back to the back end, and within the home also, that front end means that is home energy management gateway. It is communicating with the devices through Zigbee communication. So all the data, right, they have been moving within the network of the ICT, let's say. So to have effective control or to avoid any problem or hacking problem, we need to develop or we need to implement the security layers within this system. Okay, if this system is not secure, not encrypted, okay, then someone may be in a position to hack the system or to do the malfunctioning of the network, and that is going to impact not only to the customers or the homeowners also, but also it is going to impact on the network operation also. So this objective 6, that was in security and privacy, it was very important. And within my university, at University of Agder, we have some experts and they lead this objective 6, and I was also contributing on that one. Now coming back or moving forward to the objective 7, when we are talking about the demand side management, and here you can see that we are integrating the front end and back end system, and due to that, basically we are shifting the operation of non-critical power intensive loads. Due to that, the businesses of the utility companies are going to affect, okay, and somehow. So and in future, if we are going to have more demand side management system, so we have to consider that what type of changes are going to be required in the business models of the utility company, which have been covered into the objective 7. And this objective, in this objective, we used the expertise of the Swiss company. So they have very good expertise on the energy economics or developing the business model with reference to the electrical energy network. Now here you can see that within this project, even it looks like a more technically electrical engineering focused, but here you can see that how we are including the expertise of different domains together. For example, from the computer side, from the information communication side, from the business side, or those who are going to have very good idea about the energy businesses also. At the same time, we are taking the expertise of the people who are working on the security side, means on the encryption of the data side. Then at the same time, here you can see that in this project we did pilot testing in 100 houses in Norway and 100 houses in Switzerland. It means we need to have the local expertise or engineering expertise for installing such type of system in the houses and fixing the communication with the devices, as well as integrating the ICT infrastructure there. Okay, then another thing here, integration of front-end and back-end system, again that is more or less more from the computer domain side. Then objective 3, that was basically aggregation of intelligence. So here again it is more on developing the programming, but having the core knowledge of the electrical engineering side. So with reference to this project, you can see that how we are in a position to integrate the expertise of computers, electronics, software development, electrical engineering, field engineering, security, businesses, all together for achieving the key objective of demand side management. Okay, so this is a very good, means like how smoothly or how we have to work in integrated way. So this project or the objectives of this project is going to be very useful if we are going to implement the new education policy 2020, which have been approved by the government of India. So that new education policy is also basically what it is doing. They are also integrating together the different domain knowledge, okay, in an integrated way, so that we will not work in a very silo mode or in independent mode, but we have to work more, or we have to develop our teaching program more on integrated way. So here you can see that how such type of projects can help us in redesigning our teaching or the curriculum also. So now we will move to the next slide. So in the next slide here you can see that we have the front end system and the back end system. And the front end system, basically that is a home energy management gateway. And this home energy management gateway, right, I mentioned that this has been developed or the product, it was from Devolco product. And on that gateway, Ogema operating platform have been implemented. And this Ogema platform, it was basically provided by the Fraunhofer Germany. Okay, and in a particular house or in the selected house, this front end system or the home energy management gateway, basically it was the size of our mobile, they have been installed. And then the power plug or the let's say the controller for the selected devices have also been installed. And then those selected device controllers, they were getting the information or the signal from this home energy management gateway through Zigbee for shifting their operation. Okay, so within the house there was a communication through Zigbee for the loads. Okay, and in some of the cases maybe there may be renewable energy integration also, so that also we have to take into account. So but we didn't did that in this project. Then at the same time, this home energy management gateway, it can get connected to our mobile device also, and there we can have one application, and through that we can see that at a particular time which type of load has been shifted, how much energy has been consumed, how the peak demand have been reduced, and so on and so forth. So that is at the front end. Then if we come back to the back end side, so back end side, here we have the virtual power plant, which was taking into account the aggregation of all the household demands, as well as the aggregation of intermittent renewable energy production, and considering the grid constraints, especially on the distributed networks, or maybe more at the feeder level also. Okay, based on that, this backend system or the virtual power plant system used to generate the demand side management scenarios, and that DSM scenarios have been communicated to the home energy management gateway through 3G communication, and then based on that, the operation of the non-critical power intensive load have been achieved. Here you can see that the backend, that is a virtual power plant, and in the second slide or third slide I mentioned that that has been the property of the Fraunhofer Germany. So this virtual power plant, it was located into the Germany, and this front end system or the home energy management system, they have been located in Switzerland and in Norway at different locations. So here you can see how the different geographical locations have been integrated together through this ICT infrastructure for managing the local operation together. Okay, so that is a really a very good thing what we are talking about, the cyber physical system. And this cyber physical system is going to be the part of industrial revolution 4, and based on the industrial revolution 4, we are going to have the changes in our education system also, and that changes are going to be considered as education 4 or a revolution in education as education 4, which is going to be based on industrial revolution 4, and that industrial revolution 4 is considering the cyber physical system. So here you can see that the learning from this project is going to be useful for not only for the industrial revolution 4, but also revolutioning or changing our education platform also, considering industrial revolution 4 and moving towards the education 4. Is it okay? So this is a very interesting and important point. And then of course, when we are doing all this communication here, so security and privacy management are going to be very important. And at the same time, because we have to see the business angle also, so how such types of system are going to impact the business models of the utility company as well as the home owners also. Okay, if we take this load shifting diagram here, okay, this graph, it looks like a very simple, just we have to shift the operation of the loads and we have to make this load curve more flat or improve the load factor. But to achieve that, here you can see that how we need to integrate, right, different infrastructure together. Okay, so to be operated as a cyber physical system more in automated way. Okay, so now here this is a more like or less front end and a back end integration system. Front end system, we have the home energy management system. On the back end system, that is the irrigation, where we have the virtual power plant. And this front end and the back end system, they have been basically integrated with wider area network. And in the front end system, we need to have many sensors, actuators, meters, etc. for shifting or controlling or managing the loads. Similarly, on the backend side, we need to have aggregation of the household demands. 1 point. Second, based on that, then we need to do the analysis of the forecasting of the home energy or the domestic loads also. Then at the same time, why we want to utilize this? Because we have some limits of the grid constants, and at the same time we want to promote the renewable energy sources. So we need to consider the forecasting of the load as well as the forecasting of the renewable energy sources. And we used in this project the centralized approach. So it means that load control or the scheduling has to be done from the backend side. So that is going to be happening through the virtual power plant. And then backend system is going to get the information that how the users are behaving and how the appliances they have been managed. At the same time, then we have to consider that alarm and event handling also, and of course the data which we are going to be collected from this project, right? So how those data can be further analyzed for finding out other opportunities of implementing such type of system here. So on the customer side, basically then we are talking about the front-end system. So we need to do the profile management, monitoring, information getting the information from the backend system, and of course then this how we can interface this front-end system to our mobile device through some applications also. So that is again is another point which we need to consider also. Then if we come to the backend system, so backend system is more like a distributed system operator or transmission system operator. So they have to do some energy management system. They have to make sure that users have their continuous power supply, okay, and there should be proper reliability issues also that we need to, that DSO and TSO has to be considered. So that has going to be under the backend system also, monitoring and whatever the data they have been collected. So one has to do the statistical analysis also, but that statistical analysis of the collected data, that is going to be more focused on the DSO or TSO side. And basically then it is going, this is such type of system is going to work as web services or software as agents. Okay, so here you can see that how the front end and back end system have been integrated together using information communication technology for shifting the operation of domestic loads in the smart grid environment. Okay, so now here this is more or less a software side or integration of the blocks together. So here you can see that front end system and back end system, how they have been integrated together. Or so basically this is more or less related to the objective one. Okay, on the back end side, this here you can see that we have the virtual power plant which used to send the scheduling to the home energy management gateway, and based on what? Based on the aggregation. Aggregation means like collecting aggregated forecasted demand from the domestic loads as well as aggregated forecasted demand from the renewable energy sources. Based on that, the scheduling of the loads have been generated from by the virtual power plant and communicated to the home energy management gateway. So here you can see that how the flexibility forecast have been utilized, okay, for with reference to the grid constants also, for shifting the operation of non-critical power intensive load, where we consider the DSO and grid constants also. So here you can see that how this front end and back end system, they are going to work in a very intelligent way and integrated way with reference to the real time also. Okay, so that they can offer flexibility to each other and consider the grid constraints as well as the more promotion of renewable energy sources, or more or improving or more power supply or energy supply from intermittent renewable energy sources and reducing the supply from the conventional power plants. So this is a very good and very good integration of the back-end and front-end system. Now coming to the implementation side, so the design and implementation of a flexibility forecast service at Fraunhofer, which have been used as a virtual power plant in this project as a back-end system, and it also take into account the grid constraints, okay, not only within for the distributed network but also considering at the feeder level also and household levels. So then that design and implementation of grid constraints with reference to the demand side management or shifting the operation of power intensive load at a particular time, okay, that has to be considered in this point here, which has been implemented basically. Then another very interesting point here, you might have seen that when we are talking about integration okay, and everything is going through the communication, okay. So important thing is that how security and privacy are going to be there. So in this project, we developed the prototypes for the security layers, implemented into the home energy management gateway, as well as in the backend system for the proper encryption, so that no one should be in a position to hack any data or switch on and off of the devices, right? So that the users may get a discomfort or users power supply may get disconnected. So for that purpose, here you can see that how the security and privacy are going to play the major role for smart grid energy management system, and those points had been covered in this project. Then implementation of a front-end system. Okay, front end, as I mentioned, the front end system, it was a home energy management gateway, and that gateway have been provided by Devolco products. And in the Devolco products, Ogema platform from Fraunhofer, they have been included. Okay, the full form of the Ogema is Open Gateway Energy Management System. And this Ogema platform is to get the signal from the virtual power plant through 3G system, and this Ogema unit or home energy management gateway, let's say, is communicating through the to the selected device, right? So through Zigbee communication, then we need that smart power plugs or the controllers for the devices also to shift the operation or manage the operation. So here you can see that how the hardware facilities which have been provided to for this project by Devolco, they have been used. Okay. Then another very interesting point, because in houses we have so many loads which we cannot control or manage, and due to the climatic conditions of Norway as well as Switzerland, every house they have the boiler load, and these boilers they have been basically connected to the electricity, means electrically heated boiler, and due to their thermal inertia, so it is very easy to control or shift the operation of this boiler loads. So in this project, we have selected the boiler as a main load, okay, in Norway as well as in Switzerland also, for managing or shifting the operation of this load, so that the users, okay, don't have to face any problem if we select any other load, because it has a thermal inertia. Okay, so then here again you can see that the front end system, which was integrated using message oriented middleware, and this HESSO, that Swiss university, they have very good expertise on this middleware, so we used that expertise in this project. Then another thing which I mentioned you earlier also, that telecommunication system is basically information communication system. So NetPlus, which is a Swiss telephone operator or mobile operator, so they provided their facilities for managing this load. Okay, and they were also the partner here. And now here you can see that NetPlus, it is a Swiss company, okay, and we have Switzerland company, and we tested this project not only in Switzerland but in Norway also. So from Switzerland they also provide their mobile system or telecommunication system to the Norwegian pilots also. Okay, then design and implementation of a flexibility forecast, right? So that one was basically in the Germany, okay, Fraunhofer, and you can see that Germany Fraunhofer facility have been used in Norway and Switzerland, and the products were developed in Denmark. So here you can see that how these different geographical locations or different organizations, they have been integrated together for implementing these pilots in 2 different countries. Okay, so that is a very interesting and very good to learn that how we have to work smoothly in a very integrated way. Then here the flexibility forecast service, that was from Fraunhofer, which I mentioned earlier also. And for this virtual power plant, the stochastic scheduling have been implemented, And this stochastic scheduling used to generate the demand side management scenarios for shifting operation. Then this intelligence scheduler means basically the algorithms for shifting the operation of selected loads. So here we used a centralized approach, and then another approach, that one was decentralized. So that we didn't test it, but we developed in this project also. That is called, we call it as a decentralized home energy management system approach. And for centralized approach, Aarhus University, they also heavily contributed in that one. And when we are developing this algorithm, or when we utilize this or developed algorithm for shifting the operation, the grid constraints were also used at the feeder and the household levels also. Then security layers in the home energy management gateway as well as in the virtual power plant, they have been tested, implemented, and the loopholes have been also found out on them, and those loopholes have also been rectified. Okay, and devoting, which helped us in doing the analysis on the testing configuration of the houses, and also installing the system or making the system ready for the pilots in Switzerland and the Norway. Then MIS Energy on platform, basically it is more or less related to analyze the business model with reference to the flexibility trading or electrical energy flexibility trading, I can say. And then the main technical results, as I mentioned, that 100 houses in Norway, 100 houses in Switzerland, the system have been tested, and there were a lot of problems also, how we have to recruit the houses, how we have to do the installation, configuration, and operation also. In some of the houses, maybe due to the quality are like that, there may be some failure of the internal communication through Zigbee also. So all those challenges were there. But in first 2 years of the project, we worked on research and technology development. And on the third year of the project, it was more focused on the pilot side also. Okay. So here you can see that during the pilot, some security demonstrations have also been done, and some new vulnerabilities have also been found out, and they have been rectified also, and improved the security layer. And there were some problems on the heating system also, especially in the Swiss part of the pilot. Okay, so that has also been rectified. And then again, based on this advice or the recommendation from the European Union, they said that we should do the or we should provide the results of around 200,000 houses if those houses are going to implement such type of demand side management system. So our Swiss partner, so they developed a simulator, and within that simulator, using the technology or the configuration which we used in this project, and we got the results for 200,000 houses, and how these 200,000 houses are going to impact the operation of the grid, that also have been studied in this project. Okay, and if you are interested in this project outputs or the technical reports, so if you Google on this project's name, and then you can find most of the technical deliverables from this project on Aarhus University website, or maybe on the European Union Framework 7 website. And I request all of you to utilize these deliverables or the reports from these projects, okay, for your research work or for your teaching also, because it is a publicly funded project. So we should have as maximum utilization of all the results which we received from this project for the wider community, and also for sustainable development of our society. And of course, this project is going to help with reference to the distributed network operation, or how we can make it more smarter using home energy management system. How we can integrate the information communication technology infrastructure for that purpose. That also, you can learn from this project. Okay. So thank you very much. Hello.
Hello. Thank you so much, sir. It was nice session. Sir, one questions from the participant.
Yeah, now because till this
Yes.
moment only I was talking, and how there was not any live interaction. So that is the
Yes.
problem with the webinar. So we cannot see that how the people they are interacting,
Yes,
or
sir.
we cannot see that their faces or not their energy, like are the vibes. So now we need to make it more interactive from the
Yes, sir.
participants. Like
The
so,
question, yes, sir. The question is, what are the key points that we have to taken care during audit work?
during
Audit work.
what type of audit you are saying? Like means like selection of the houses, or
That
or
audit is industrial. That audit is industrial.
yeah, this is a very good point. Means let's say if the question is related to the energy audit, for example,
Yes,
let's
sir.
say we did some energy audit of any industry or any residential building also, or any institutional building also. So we can do the analysis of that building or institute or industry through energy audit about the load profile, which type of loads are there, which are critical load, which are non-critical load, which are more inertia, like that. And based on that, we can identify some load which are not critical but can contribute towards the demand side management. And then we can use those loads for shifting the operation, or maybe let's say reducing the peak demand on the network, or maybe in a simple way making load core more flat. So the energy audit is like basically the first point moving towards the energy management side.
Yes, sir.
What is the second question?
Yes, sir. Sir, there are no more questions regarding the audit work as well as the audit project.
Yeah. How many participants are there total now? Because I cannot see the list here.
Yes, right now around 16 participants are there.
Very good.
Yes,
And
sir.
you are, is it live telecast or how they are participating?
Sir, it is a live telecast. Yes, sir. Okay, sir. So we will stop our session right now, and in future we will really, for future we will interact with you for further session like today's session. So thank you so much, Professor Kolhe, sir. Thanks a lot.
Thank you very much.
Yes.
Excuse me, sir. Hello, sir.
Yes, sir. Nikun sir is there, sir. Yes.
From the SREE SWAMI ATMANAND SARASWATI Institute of Technology and DST Group, I am really thankful to sir for accept our invitations and serve such a wonderful information. Once again, sir, thank you very much from the bottom of heart, and thank you very much for spend your valuable time with us.
Yeah, it's my pleasure to be with you. But let's say in future when we have the normal situation, and if the travel and everything goes normal, then I would like to visit your institute sometime, and then to have more physical interaction with your academic staff and the students also.
Definitely, sir. We are also interested to invite you in future. It will be our pleasure. So thank you, sir. Definitely.
Thank you.
Okay, sir.